Our last section of Chapter 7 is going to introduce our final trig identities for this chapter. And they're going to be ones that are a lot lengthier, definitely not something I anticipate you memorizing, more so just being able to use, and not something that we're actually going to use a great deal of. At this stage, I just want you to be able to be comfortable enough with them to practice using them to convert one to the other. We're not really going to take these a lot further than that. We're not going to throw these into identities that keep working beyond just rewriting the identity at this stage. So we've got two new formulas. The first is called the product to sum, and the second, the sum to product. So we'll work through a couple examples of both. Our first theorems are our product to sum. Remember, product means multiply, sum means addition. And in fact, here we do have some addition and some that are subtraction. So what we can do here is we can take either sine of an angle times sine of another angle, cosine of an angle times cosine of another angle, or sine of an angle times cosine of an angle, and rewrite them in terms of all sums and differences. So we're not actually having to, so we're actually going to be able to get rid of that multiplication there. And again, for the sake of this course, we're only going to practice implementing these. We're not going to have to go as far as then continuing to solve. We're just going to convert from one to the other. And the big thing that will come into play with these is remembering our even and odd functions, meaning cosine functions are even. So if we have a negative angle, it's the same thing as that function with a positive angle. Sine is an odd function, meaning if we have a negative angle, it's the same thing as that whole function negative. And that's what we'll see here in our first couple examples. So I've got three examples. We want to express the products as a sum containing only sines and cosines, and I just included down here in the bottom our theorems that are our product to sum formulas so that we don't have to flip back and forth. So the first thing we want to do is looking at A, we have sine of 3 theta times sine of 7 theta. And I want to express this as a product. So I'm going to identify which of these three formulas I'm going to use. Since I have sine for both of my terms, I'm going to be using this first formula here. Sine alpha times sine beta. That means my alpha here is going to be my 3 theta, and beta is going to be my 7 theta. Once we've got that, the rest really just becomes plug and chug and a little bit of simplification. Now you can see the right-hand side here. This is much longer. So it's unlike a lot of identities where we normally are working towards something that's a little bit easier to read. And again, we're not going to have to go as far as actually reducing this. We're just going to leave it as is. So I'm going to implement my 1/2 outside, my square bracket. Then I've got cosine alpha minus beta. Alpha is 3 theta minus beta is 7 theta. And parenthesis minus cosine alpha plus beta. So 3 theta plus 7 theta. Now I said we're just going to implement, but we always want to make sure we keep simplifying as far as we can. And since I have inside my parentheses for each of these, I can combine those like terms. So I've still got that 1/2 out front. My first term becomes cosine of 3 theta minus 7 theta is negative 4 theta. Minus cosine, and I want to combine what's inside my parentheses here, 3 theta plus 7 theta, and that gives me positive 10 theta. Now I'm almost done, but as I mentioned, we want to practice using our even and odd theorems here. We never want to leave a final answer that has a negative angle. In this case, this first term here has a negative 4 theta. Since cosine is an even function, anytime we're taking cosine of a negative angle, it's the exact same thing as cosine of that angle positive. So I can rewrite this one last time as 1/2 cosine of positive 4 theta minus cosine of 10 theta. And that is going to be my final answer. So do know when you are putting these into MyMathLab in your homework, there's going to be some lengthier answers. We're not doing as much work as we were in the previous sections to really reduce these down to simpler terms. We're just practicing implementing these last identities. So let's try another one. Part B is cosine theta times cosine of 5 theta. Here I have cosine and cosine, so I'm going to use this second formula in my box down here. And my alpha will be just theta, my beta will be 5 theta. And using my theorem here, I'm going to again have that 1/2 out front, my square bracket, cosine alpha minus beta, so alpha is theta minus beta is 5 theta, then plus cosine, now alpha plus beta, so theta plus 5 theta. Our next step, just like it was in our last example, simplify what's inside each of those angles so that 1/2 stays out front. cosine theta minus 5 theta gives me a negative 4 theta. So hopefully you're seeing here where I'm going to have one more step where I have to get rid of that negative, plus my second term, cosine theta plus 5 theta, is 6 theta. And so my last step here will be, again, to get rid of that negative angle. We don't like negatives. Cosine is even, so a negative angle is the same thing as a positive angle. So my final answer will be that 1/2 cosine of positive 4 theta plus cosine of 6 theta. So similar to my last example, but my addition in between my cosine terms is the difference than when having two sines versus two cosines. My last example here, sine of 2 theta times cosine of 7 theta. Now I have one term that's sine and the other is cosine, so I'm going to go ahead and rely on my third formula here. Again, see the similarities. It looks in a similar format to what we saw in the last example, but this time both of our terms are sine. And again, alpha is our first term, so 2 theta, and beta our second, 7 theta. 1/2 out front, sine of alpha plus beta, so 2 theta plus 7 theta, plus sine of alpha minus theta, or beta, excuse me, 2 theta minus 7 theta. Continue simplifying. 1/2, simplify what's inside your angles. 2 theta plus 7 theta is 9 theta, plus sine of 2 theta minus 7 theta is negative 5 theta. And my last step, we know we can't leave an angle negative, and we haven't worked with a sine yet in this lesson, but sine is an odd function, meaning if we put sine, a negative angle in sine, we don't just get rid of it like we do with cosine, we make that whole term negative. So instead of it being positive sine 5 theta or plus sine of 5 theta, we have a minus sine of 5 theta. So my final answer will be that 1/2. Let me try that again. 1/2. My first term stays the same, sine of 9 theta, then minus sine of, and there's our positive 5 theta. So again, we're not actually doing a whole lot of simplifying here. We're just practicing implementing, going from a product to a sum. If you continue taking a Calculus 1 or Trig class beyond this course, you will actually use those within identities to continue solving to get a left side to match a right side like we have in the past. Here it's just practice implementing them. So we've got one more set of theorems to go through, and this is where we're expressing sums as products. So kind of the reverse of what we saw, taking an addition of two trig functions and converting it to a multiplication. You can see here we have 4 different formulas. We have addition of sines, subtraction of sines, addition of cosines, and subtraction of cosines. And again, notice the similarity in how our products look. We're going to have just changes in our signs, S-I-G-N, signs, so plus and minuses, and sines and cosines throughout. So just make sure you're picking out the right theorem for each example. And we'll run through 2 of these. We don't necessarily need to practice all of them, as they'll all follow the same format as long as you're picking the right theorem.